Hello and welcome to IP lesson. In this lesson we will learn about VLAN and the trunking. Let's start with Lan Broadcast Domain. Lan Broadcast Domain is a collection of devices can communicate by broadcast. Let's take a look at our example in order to understand the broadcast domain. In my example I have one router, one switch, and 6 PCs. Those PCs from different departments. We have PC from sales, HR, IT, telecom, system ops, and net admin. If our switch receive unknown frame, we are talking about our network right now before deploying the VLAN. Our switch will flood this unknown frame, and this is the default behavior of our switch. And as you can see, this is insecure. This is insufficient for our network. Let's see how the VLAN will solve these problems. VLAN stands for Virtual Local Area Network, and the factory settings for Cisco switches is that all the ports are in the default VLAN. The default VLAN is VLAN 1. Some people also call it native VLAN. And in our example here we have Chris, Bob, they are from the IT department, Jack and James from the HR department. So after we purchase our switch and we connect the users to that switch, let's imagine that Chris wants to send data to Bob. If Bob's destination MAC address is known for our switch, what will happen is that our switch will forward the data to Bob, and there is no problem here. So what about if Chris wants to send data to Bob, but Bob's MAC address is unknown for our switch? In that case, our switch will flood this frame, and even James and Jack from the HR department, they can receive this frame. The reason of that, because our switch is located in one LAN. For that reason, we can use the VLAN. So what will happen here is that our VLAN will split the LAN to two LANs. So as you can see here, after we deploy the VLAN, when Chris wants to send data to Bob, even if Bob's MAC address is unknown, the data will not go to the HR team. Same thing for HR. If Jack wants to send the data to James and the James MAC address is unknown, the data will not go to the IT. The reason of that, because we created two VLANs, one VLAN for HR and one VLAN for IT. So after we did that, our switch became two broadcast domains instead of one broadcast domain. One broadcast domain for the IT and another broadcast domain for HR. So right now our LAN is segmented and the data is secured, and no one from team can send data to another team. Even for the outside network, when our switch receives data, it should be meant for HR, and in that case only the HR will receive this data, or it could be meant for the IT and only the IT team will receive this data. So from our examples that we saw, we can know right now what is the benefits of using the VLAN in our network. So VLAN limit receiver hosts in a broadcast, reduce the process overhead. So right now, instead of forwarding the data to all our ports, it will be forwarded only for IT if it's IT data, or HR if it's HR data. VLAN also increase security because of limited receivers. So right now we can create policy per VLAN. So we can permit HR, for example, to use outside network, and at the same time prohibit access for IT to that network. Also the VLAN give more flexibility to our network. Problems become smaller, and also VLAN reduce work of STP, which is spanning tree protocol. We will learn about the spanning tree protocol in the coming lessons. So for VLAN, the VLANs are range from 1 to 4094. As we mentioned, the default VLAN is VLAN 1. This VLAN cannot be deleted. So it depends on our network, the size of our network. We can use any VLANs to segment our LAN based on our needs. So let's continue with VLAN and see how the MAC address table will look when we use the VLAN. So before configuring our device and adding VLANs to our network, all the MAC addresses are in one VLAN. But after we deploy the VLAN, the devices are in different VLAN, and that will help us for sure to troubleshoot any problem. So what about the ports between the switches? Let's imagine that we have two switches in our LAN. We configure our switches with VLAN 3 and VLAN 2. So what is the configuration that we need to put for the ports that will be between those two switches? Should we connect one link per VLAN? So should we connect one link for VLAN 3 and another link for VLAN 2? What about if we are using 30 VLAN in our network? This is not gonna work for sure, and we need another solution to solve this problem. So for the port between the two switches, we can use another protocol called trunking. Trunking is a port type on our switch that allow data flow across network node for multiple VLAN. So back to our example, we have VLAN 2 and the VLAN 3 in our two switches. We can use a trunk port between those two switches, and this trunk port will transmit data for VLAN 2 and the VLAN 3. Even if we have more VLANs, it can go through that trunking port. So that trunking port put a tag on the data frame, and inside that tag there is something called VLAN ID. VLAN ID includes the VLAN number that we are transmitting the data for. For example, if the VLAN ID is 2, this means the data is for VLAN 2. If VLAN ID is 3, that means this data is for VLAN 3. That's how our trunking port can differentiate between the data meant for VLAN 2 and the data for VLAN 3. For trunking protocols, we have two protocols. We have 802.1q and ISL. As you can tell from the name of 802.1q, this is IEEE standard protocol. This protocol supports the 4096 VLANs. It uses 4 bytes to tag the original frame, and the only vulnerability for 802.1q protocol that it doesn't tag the native VLAN. And because of that reason, most of the organizations doesn't use the native VLAN. We have also the ISL, Inter-Switch Link. This is a legacy protocol and not used nowadays. This protocol is a Cisco proprietary protocol. It supports VLANs from 1 to 1005, the original frame encapsulated, and the new header inserted during the encapsulation. So the 802.1q insert a tag to the original frame, but ISL encapsulate the original frame and create a new frame. ISL tags the native VLAN. The next topic that we will talk about today is a protocol called DTP. DTP stands for Dynamic Trunking Protocol, and as you can tell from the name, this protocol allows us to configure our port to dynamically be a trunk port. So instead of configuring our port to trunk, we can use the Dynamic Trunking Protocol, DTP, to negotiate with the other side and see if the port will be trunk or access. So for example, we can configure our switch on the left side with a dynamic desirable configuration on interface fast Ethernet 0/0 and do the same thing at the other switch, and the result here will be trunking port. So this table includes all the configuration that we can do for our ports in order to be access port. And access port means that this interface assigned to VLAN or to be a trunk port. For example, if we configure our interface as an access and for the other side access, the result will be access. If we configured our interface with dynamic auto and access at the other side, the result will be access. We can't configure one side with trunk and one side with access. This is not gonna work. If we configure our interface with access and the other side dynamic desirable, the result will be access. If we configure our interface with dynamic auto and access, the result is access. Dynamic auto and dynamic auto, it will be access. Dynamic auto and trunk, it will be trunk. Dynamic auto and dynamic desirable, it will be trunk. Please spend some time in this table in order to understand the result of ports configuration using dynamic trunking protocol. Next we have the phone system. So this network design here refers to the classic phone system. In the classic phone system, the phones used to connect to the PBX. PBX stands for Private Branch Exchange. At the classic phone system, the phones didn't support the Ethernet. It used the telephone line, and the telephone line used the RJ11 instead of the RJ45 for Ethernet. And this telephone line didn't support the 100 megabit per second or the 1000 megabit per second speed. The classic phone system was expensive and it added complexity to the network. Nowadays we are using the VOIP system. VOIP stands for Voice over IP, and nowadays most of the companies are using the VOIP system instead of the classic phone system. So what is the benefit of using the VOIP system instead of the classic phone system? First thing, we will not run telephone line in order to connect our phone system to the network, and we don't need PBX to connect our phones. Instead, our phone will be connected directly with the Ethernet cable from the switch. The switch interface will be configured to propagate two VLANs, VoIP VLAN and data VLAN. At the same time, the interface will send power to our phone using something called PoE, power over Ethernet, so we will not need a power connection to our phone, and our PC will be connected to the phone. So our phone will open the VoIP data and read it, and for regular data, the phone will forward this data to the PC. And this is an example of the modern VoIP system. As you can see, it's very simple compared to the classic phone system. This is the end for this video. Thanks for watching and see you in the next one.